everybody, we're back for another installment of Pre-Calculus. Yes, Pre-Calculus. Okay, today we're going to be talking about section 2.2, Polynomial Functions. In this section, hopefully you remember that a polynomial function is something that looks kind of like that. No, that's a monkey. What am I talking about? Polynomial function. Duh! Something more like that. Yay? You can still see the monkey. Okay, so pretty much that's a polynomial function, or that's a polynomial function, or wrong side. That's a polynomial function, right? Pretty much just something that has smooth curves, and it is continuous all the way through. That is something that we call a polynomial function, because it has more than one nomial, which is just more than one term. Polynomials, kind of like polygamy is more than one wife, but not really, so we don't talk about that. Blah, 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 blah. I don't know what Mr. Pike is saying, but he's crazy. Okay, so with this, we have something that we call the leading term test. This is also the leading coefficient test. Some of you people may want to look it up online. Leading coefficient test, right? This term, that's just what our book calls it. They call it the leading term test. So if we are given a function, f of x equals ax to the n plus bx to the n minus 1 plus blah, 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 plus some constant. As long as n is the highest power, these rules apply. So on this side, this is talking about n, and on this side, that is talking about a, so the term in front of it. So really the only thing that we are going to be focused on in the leading term test is the nomial, or the term that has the highest power, and then whether it's positive or negative. That's the only thing I care about. So if n is odd, right, something like x cubed, it would look something like that. All we're really focused on is the n behavior on that graph as well. If it is negative, something like negative x cubed, notice it just flips it over the x-axis or y-axis, whichever way you want to look at it. Actually, let's say the x-axis because it's not on the inside. All right, and if we have an even power, that would be something like x squared or x to the fourth. If it's an even number, it will look something like a parabola. Just remember, in the n behavior is the only thing I'm talking about. And then negative x squared will look something like this. It just flips it. Yay, that's all we were talking about when we were talking about the leading term test. All right, make sure you guys are still pausing the video in this chapter. Write down the example, try it, think about it, love it, don't love it, whatever you're going to do. So, and then you can play the video and watch me do it. Yay. Oh no, I marked on the paper. It's not there. You don't see it. Okay, so with this, describe the n behavior. We know with the n behavior, we're going to at least say as x approaches negative infinity, and as x approaches infinity, y, or f of x, approaches, okay? And then I'm just going to be pretty much filling in the blank. Now with this, with our leading term test, we're going to do this. I look at the one with the highest power. The term with the highest power is negative 5x to the 7th. Notice kind of on our chart, negative 5x to the 7th, well, it is a negative number, and it is odd, so hopefully it will look something like this one here. Okay, so if we have it odd, we know it's like the cubic, but it's flipped, so it's something like that in the n behavior. So you don't even have to graph this one. You could if you had a calculator to kind of look at the n behavior, but why use a calculator if you can just do it way faster in your head? It doesn't make sense, does it? So as x approaches negative infinity, or goes this way forever, it looks like my graph is going up, so it is going to infinity. And as x approaches infinity, or goes that direction, looks like my graph goes down forever, so it goes to negative infinity. Yay! All right, looking at another one of these. So again, we can start off by at least saying, "Woo!" Ha! All right, faster than you. Okay, so we have this part. Notice this time I wrote h of x because instead of f of x, I have h of x, so it's a different function. Okay, and then I'm going to look at the highest term. This time the highest term is back here. It is to the 8th, which means it is an even function, so it'll look kind of like a parabola. It is negative, which means the parabola will kind of be going downish. Downish, not downish. It is going down. So as it goes to negative infinity, it goes to negative infinity on the y direction as well, and in the x direction. So it's going down in both directions to infinity. Okay, this one's a little bit different. Only in the way that it looks. I mean, we're still doing the same thing. We're going to be looking at the term with the highest coefficient. So notice on the outside here I have negative x times x minus 4 times x plus 5. So it looks like I'm multiplying 3 x's together, so hopefully this should come out like something like x to the cubed. You have a negative in front, so that will be something like negative x to the cubed. So if you see that right away, boom, boom, you can say your end behavior. If you don't believe me and you really want to multiply this out, you can multiply this out. Have fun doing that. I will show you how you do that, but it's not as exciting as one may think, because we will still come out with the end result being negative x cubed minus x squared plus 20x. Ah! Okay, and our highest coefficient, hey-oh, look at that, right? Called it negative x times x times x. If you're multiplying 3 x's together, it's going to come out x cubed. Since it's negative on the outside, it's going to be negative. So we have something like this. So again, let's write our end behavior. And it looks to me like as x approaches negative infinity, our y is going up forever, so it's going to infinity. As x goes to infinity, g of x will go down or to negative infinity. Yay! Alright, this one was on your Chapter 1 test. Hopefully you guys did really well on that. If you didn't, make sure you study harder. The way that you study harder is just doing more examples. Hello, Mr. Sudbrook. He is in our video now. Everybody say hi to Mr. Sudbrook. Hi, Mr. Sudbrook. Oh, he's trying to escape. Where is he? There he is.
Why am I upside down?
The video's upside down.
Okay.
Mr. Sudbrook got scared. He was video shy. No, I'm just kidding. He was really happy to be in the video. He said, thanks, man. I think. I don't know. Anyways, so like I was saying, to study, what I would do is write the problem without anything else. Don't look at any notes. If you can do it without notes, then you are good to go. You will probably make 100 on the test if you can do everything without notes. Like if you start off that problem with only the things in black. That's why I write them in black. And all of the other work that I do it in other colors because, hey, oh, that's all the work. Okay, so as long as you can do the things in black, well, from the things in black, right, in black pen, then yeah, you should be good to go. If that made sense, I hope that you are, I don't know. If that made sense, then do it. I don't know what else to say. Practice. I get better at basketball by playing basketball. You get better at math by doing math. Hey, oh, go figure that. Okay, so this is your cubic function. Don't forget that this is inside with the x, so this is going to move everything to the right 6. So 1, 2, 3, 4, 5, 6, and then over 1 up 1, do 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 do, and there would be a graph. Yay! All right, this one we are also going to be graphing the function. Notice we have x to the 4th this time, 32 x to the 4th plus 7. So I know this plus 7 is going to move it up 7. This 32 is going to multiply the y's by 32. And then to the 4th, really that means it's just going to look like kind of a parabola. So if I move that up 7, multiply the y's by 32, 1, 2, 3, 4, 5, 6, 7, then it's just going to be a very vertically stretched parabola. So it'll be something like that. All right, last one of this type. So graphing the function again. It looks like that is going to move it to the left 2. I have to the 5th, so I know it will look something like that, especially since it is positive. It's not being multiplied by any negatives. So if I have 1/8 x to the 5th, and it's moved left 2, 1/8 will make it shrink vertically shrink. All the y values be multiplied by 1/8, so it would look something like that maybe. Cool. Alright, here we go. Cracking the knuckles, because this one's going to be fun. State the number of possible zeros. So I will tell you that the possible zeros is just how many, or whatever your highest exponent is. So with this one, the possible zeros would just be 6, because there are 6 possible zeros. Turning points is whenever it changes direction. So if we have a function like that, that would be one turning point, and that would be another. Pretty much just your max, mins, relative, absolute, whatever. Real zeros is wherever it crosses the x-axis, and multiplicity of each zero, I will talk about that in 1 second. So first, I'm going to try to find each zero. Well, I know to find each zero, the y value is 0. So I can substitute in that because this is just an x-intercept, right? X-intercept where I have some x value. I know the y value is 0. Well, I notice that there are at least 4 x's in all of these, so I can factor out an x to the 4th. So x to the 4th, and I'll be left with x squared minus 8x plus 12. This will factor on the inside, so I'll have 0 equals x to the 4th times x minus 6 and x minus 2. So then from there I can pull out my zeros and say, well, this is one of my zeros, x equals 0. Oh, if my pen will write, pen right pen. X minus 6 equals 0, so x equals 6. X minus 2 equals 0, so x equals 2. Those are 3 of my real zeros, or my only 3 real zeros, really. So now with multiplicity, talking about multiplicity, multiplicity, it is just the exponent of where you got your 0 from. So like this x to the 4th, I got 0 from that. So this would have a multiplicity of 4. This x minus 6 is like it's to the 1st power, so this would have a multiplicity of 1. This x minus 2 would also have a multiplicity of 1. Okay, so what that tells us is we can actually now graph our picture pretty much exactly how it's going to look without even having a graphing calculator. Yay! Check this out. Okay, so with the graph, I'll know that I'm going to cross at 0. I know I'm going to cross at 6, and I'm going to cross at 2. My highest degree is x to the 6, so my leading coefficient test, leading term test, my bad, tells me that my graph will look something like that with n behavior. But with these, now as far as multiplicity goes, if it is an even multiplicity, let me write this in a different color. I need another color. Oh, more colors. If it is an even multiplicity, it will bounce off that 0. If it is an odd multiplicity, it will pass through that 0. Bounce pass. All you basketball kids out there. So if I know that I have to start from up here, I will start from up here and I will bounce off of this 0 because that has a multiplicity of 4. 6 and 2 both have a multiplicity of 1, so I will pass through both of those. And that should be pretty close to what we have. Okay, like I said, the maxes and mins won't be necessarily exactly perfect unless you calculate them yourselves, which you can, but well, I'm not going to ask that from you. Just to show you kind of comparing our two pictures, this is my y window is going from negative 200 to 200 in the y direction, and x I left it alone is going from negative 10 to 10. But I can see on my I can see on my graph I'm starting from up here, just like I'm starting up there, and then I go down, it bounces off of 0, just like it does here. It bounces off 0, goes back through 2, goes down a while, comes back up, goes right through 6, and there's pretty much my graph. That's all we're going to ask you guys to do. And now for our turning points, that's the only thing we haven't talked about yet. We found our possible zeros. There are 6 of them. Turning points, it looks like I have 1, 2, 3 turning points. So I have 3 turns. My real zeros were my x-intercepts, and the multiplicity of each was this part right there. Cool. This one looks fun. I'm really excited to do this one because I like math. Yay. Okay, state the number of possible zeros. Well, it looks like 8 is my highest power, so I have 8 possible zeros. Number of turning points will determine, real zeros will determine, and multiplicity we will determine. So with this, if I try to find my zeros, I can at least factor out a 4 from everything, so that I have 4x to the 8th plus 4x to the 4th plus 3. Now it looks kind of weird, but I promise it'll factor. It'll factor. So I have 4x to the 4th, x to the 4th, looks like plus 1 plus 3. Yep, and that's all that will factor. So then in finding the real zeros, this is not included in one of your real zeros. So now we have ourselves in a bit of a predicament, because if we take x to the fourth plus 1 and equal to 0, then I'll have to do x to the fourth equals negative 1. And if I take the fourth root, well, that would end up as an imaginary number, just like it would for this one as well. So this one actually has no real zeros. And if you look on a graph, bam! We see something like this, which we also notice we have one turning point. Yay, one turning point. Yay, there's one of those. There's 8 of those. There's no real zeros. So obviously if there's no real zeros, there's no multiplicity of any zeros either. Cool. Giant pink banana! Alright, here we go. Last one of these types, and then we only have 2 more, and then we'll be done. Yay! Okay, so with this one, state the possible zeros. Well, we have 2 and we have 3. 5 is our highest power, so 5 possible real zeros. For the turning points, again, we'll determine later. We'll determine all that later. So if I substitute in, I'm trying to find my real zeros, x plus 2 squared and x minus 4 cubed. Hey, oh, that's already factored for me. So this 0, I will have x equals negative 2. This 0, I will have x equals 4. Looks like the multiplicity on that one is 2. Multiplicity 2. Multiplicity 3. Yay. So then on a graph, I'm going to hit negative 2. I'm going to hit 4. And now with our highest power, with our leading term test, right? That's what we call it? Yeah, leading term test. To the second, to the third, x to squared, x to the third, make x to the fifth. It is negative, so I will know it will look something-ish like that in both directions. Since this one has a multiplicity of 2, it is an even multiplicity, which means it will bounce off of that homie. And then this one's a multiplicity of 3. It's an odd multiplicity, so it will pass through that homie. So negative 2 and 4. I'm going to bounce off of this one, so I'll start from up here. Bounce off of it. I start from up there because that starts from up there. So I'll bounce off of it, go up, come back down, and keep going through because that one I passed through. There would be your picture. And it looks like it has 1, 2 turning points. 2 turning points. Yay! On your test, quiz, everything like that, make sure that you actually write this off to the side. You say like 5 possible zeros and 2 turning points. Yay! Math is fun. I like money. Alright, last type of problem. These types of problems are fun to me because it's pretty much just telling, hey, can you multiply and distribute properly? And then it shows me if you can or not. So hopefully we all can. I know we all can. I believe in us. Yay, we're all winners. Thumbs up. Yeah. Part of the thumbs up. There's all the thumbs up. Yeah. Oh, yeah. Bring back the Kool-Aid, man. So polynomial that has the given zeros. So I'm told that these are my zeros. Just like in the last one, when I pulled out my zeros, x equals negative 2, it went from the factor x plus 2. So see how that's kind of how they link together. Negative 2 plus 2, 4, negative 4. Whoa. So if it tells me that my 0 is 3, then I have a polynomial function. Make sure you write f of x or g of x or monkey of x or banana of x or whatever of x. The 3 must come from the factor x minus 3. The negative 2 must come from the factor x plus 2. And the negative 6 must come from the factor x plus 6. Now I will tell you that you can put squared or cubed or whatever you want up here. It makes no difference. Just like our zeros here, I had negative 2 and it was squared, it's still that's 0. 4 was cubed and still that's 0, right? But you're just going to make yourself or your life a little bit harder if you put a cubed or a squared, because then you'll just have more multiplication. So as is, I'm just going to multiply it out, assuming that these are all multiplicity of 1, unless it tells me otherwise, which it does not. X times x, I believe, is x squared. And then we will have minus x minus 6, and then I can have the times x plus 6. Do not multiply all of these out at once. Please, 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 please do not multiply all of these out at once. You will get the wrong answer, and I will have a sad face on my face when you're grading your test, your quiz, and everybody in class will see my sad face grading your paper, and I will be sad because I'm telling you not to do it. Don't do it. It's a trap. It's going to trick you. Okay, anyways, then you can distribute x squared to both of these terms, so it would be like having x to the third plus 6x squared. And then distribute the negative x, so minus x squared minus 6x. And distribute the negative 6, so minus 6x minus 36. And then it's just a matter of combining like terms. So combine like terms like crazy. Have a good time. Enjoy it. X to the third is all by himself. He's so worried. 6x squared minus x squared is plus 5x squared. Negative 6x and negative 6x make negative 12x and negative 36. There's our polynomial. Oh boy! This is our last one. Yeah. Alright. So polynomial function. We'll call it, I don't know, t of x this time. That has the given zeros. 1 must have come from x minus 1, 2 must have come from x minus 2, negative 4 must have come from x plus 4, and 5 must have come from x minus 5. 0 must have come from just x. Cool. Yeah, if you don't remember, check out other side of the paper. That one. Yeah, where x to the fourth just came out 0, right? Set them all to 0 and solve. Okay, back to it. I didn't do that. I didn't accidentally spit on the paper. That's gross. Ew. Ew, nasty. Sorry. It happens, but I don't want to rewrite it all. So, anyways, if I multiply just these two, and I multiply those two together, I will still leave my x on the outside, and this will come out x squared minus 3x plus 2. And then I will have x squared minus x minus 20. I don't know why my x's are coming out especially. And if you guys make fun of me for that and I just noticed, then oh well. And then it's just a matter of distributing everything here to everything in this trinomial. So I'll still leave that x on the outside. I'll just wait till the end to distribute that. So x squared times x squared, x to the fourth, minus x cubed, minus 20x squared. I can't write small enough for this. I need to start writing really small. I'm sorry. Oh, I'm gonna run out of paper. Minus 3x cubed. Ooh, it's so close. Oh, oh, can I fit another 3? Oh, I'm so close. I'm running out of room. I guess I could just get another piece of paper under this. That's too easy. Minus 2x. Oh, come on, you can do it. Minus 40. Yeah. Look at that. Look at that. I did it. I did it. I did it. I did it. And then it's a matter of you can combine like terms. I'm going to do that before I distribute the x. I'm going to move this over a little bit though so I don't run out of room. Even though it can be condensed, and I'm not going to run out of room anyways. Minus x cubed minus 3x cubed is minus 4x cubed. 20x squared and 3 is negative 17x squared. Oh no! I forgot about that one. Mr. Black Donut, no. Oh no. So that should be minus 15x squared. Well, good thing I did move this over. So I have x cubed, I did that x cubed, I did this x to the fourth, negative 20x squared plus 3 is negative 17, negative 15. Now I need to get all my x's, even though I broke up with them and I don't really want them around anymore. Plus 60 minus 2 is plus 58x. That's mean. My x's are nice people. I didn't mean that. I'm sorry. Minus 40. Maybe they're watching this and learning pre-cal. That would be funny. Oh, I shouldn't laugh at that. That's not funny. I hope you're learning pre-cal, whoever you are. It doesn't matter. Okay, then you can just distribute the x's. So in the end, I'll write my function t of x equals x to the fifth minus 4x to the fourth minus 15x cubed plus 58x squared minus 40x. Yay. Super long, super fun. Hopefully this video has been informative. It's a little bit longer than the other ones, but I wanted to make sure to do a lot of examples so that way if you have questions, you can answer them. That's all I got for you guys. Have a good night, weekend, whatever you're doing right now. Bye-bye!